Hello everybody and welcome to another tutorial video for the Detectorist Guild. So this time we're going to have a quick look at the marker system in the world. If I jump straight in, I can demonstrate what we're talking about. So we have our player character and grid system around. You'll notice at the bottom left I've got my inventory system and it's the survey markers that we're looking at. I can scroll left and right if we want to be in survey. Notice we've got 10 of those. If I right click, right mouse button, and I'm within this certain radius of these 9 squares here, I'm able to place one within that space. It will always clip or snap, I should say, to that kind of center left point on each of those squares, so it's always a consistent placement. If I try to click anywhere outside of those 9, it's not going to work. If I move my character a little bit further away, again, so it's the radius that follows, and if I use them all up, once I'm out, then I'm out. The only other functions are if I click on any of the markers, I have these options to change the colors. I can change it to green. I can change this one to red. So to very quickly talk you through what's going on there. So if we go into the inventory where all the code is, I've placed everything into kind of a sequence, so it's easy to talk about exactly what's going on. So we start, excuse me, we start, as you can imagine, with the clicking of the right mouse button. This has a switch on integer, which will change depending on the integer which is connected to the inventory. So that's the reason why if I was right mouse button clicking whilst the inventory wasn't, whilst the scroll I should say wasn't in the correct place, it wasn't identifying the marker, then nothing was going to happen. If it is set into the right place, so place marker in the world, so the selected slot is set to 0, which is elsewhere in the inventory, then it will go through the process of placing the marker. So the first thing it will do is it will check if I actually have any markers already in my inventory. So we start off with a stack of 10, but obviously that diminishes over time. So this would be the first thing which would stop a marker being placed in the world. So it's going through the inventory structure, which is a placeholder here. I've got, as you can see, I'll just scroll that out a little bit so you can see it. It's got the 3 items which were already in there. We've got the shovel for digging, we've got the detector for scanning, and in index 0 we've got the survey marker with a stack of 10. So when we try and place that marker in the world at first, it goes to that structure and it checks in obviously slot 0, index 0, to check the stack. And if that stack is not equal to 0, so basically if it's anything above 0, then that will be classed as true, and we will move on to the next stage. So that next stage is the process of snapping that marker in place. Now there's quite a little bit of kind of math code which was in there, so we have to double click on that to open it. So we've got a separate function just to try and keep things a little bit tidy. So opening up the snap selected item to world, we can start here with the get location under cursor. This is a nice useful little node here, which means every single time I press the right mouse button, it will get the real or the full world location of basically where my cursor is in 3D space. Obviously we don't need any height information because it's all about the X and Y kind of across the floor of our game, and we need to go through a little process to basically kind of round up to the nearest 100 to make sure that we are snapping our markers into place correctly. So I've just drawn up a little example here. So let's just say my precise location under the cursor for the x-axis was 547.56. It'd be a simple process of taking this divisor multiplier value that I've got here, this little variable which is always set to 1000. It would simply divide that value of 547.56 by 1000 to give us this figure here. We then use the round function to translate it into a full integer, which would translate it to the nearest. That would round it down to 5. We then multiply that value by exactly the same value of 100, so hence why it's called the divisor / multiplier, and then we're set. We've got 500, and then we would just repeat the process with the y-axis. So whatever the y value was, we would divide that by 100, round it up or down to the nearest, and then we would multiply it by 100 again. The difference you can see here is there's a little minus value of 35, and that's basically to make sure that for the y-axis we're right in the middle and on the left hand side. So if we go into play again, if it wasn't set in that particular way, then you wouldn't get the marker nice and neatly to the left hand side in the center. So the 35 is representative of that. That's what places it nicely in the middle. I didn't want it in the corners. I felt that placement in that particular arrangement was the nicest way to do it. Made it the easiest to be able to move through the markers and so on. So now we've looked at snapping the marker in place. The next thing we need to check is that the target location is near enough to the actual player. This should be a little bit more straightforward. So once we've gone through that snapping process, we get the player character. We're able to pull out from that and get the actor's location. Again, we only need the X and Y, and that gives us a vector 2D. It's a little bit messy here, I must admit, but that will go into this comparator here. And then we also get this Y value of plus 35. Again, this is to make up for the minus 35 that we put in the snapping marker to place for the Y-axis, and then the X-axis, the X value, sorry, which we've already identified. So the X and Y have already been set in this snap selected item to world. So we've checked that, added 35 to compensate for the minus 35 in the other function. And then we've got the X, and then we basically compare that vector 2D against this vector 2D for the actor's location, and then we give ourselves a radius of 150. So the larger that radius, the further I could place items. So I may be able to, say for example, change that to 300, compile, and now I can probably get away. I can, so it's not just my inner layer, I can get quite a bit further, so I could change the range if I wanted to. We'll just change that back to 150 before I forget. Okay, so once we've checked that the target location is near enough to the player, obviously with this boolean we make sure that if it isn't close enough, nothing happens, and the function effectively ends there. The next thing we need to check is that we don't want to be placing any markers that are already in place. So the first thing to do, rather than checking where all the current markers are to make sure there isn't any overlap, is just to check if there are any at all, because the first one you place, there won't be any at all. So we have this actor here that we've created, or this array of actors here that we've created called spawn markers. You'll see how we use that or kind of add to that or build on it a little bit later. But the first thing to do, obviously that already exists, and we want to check the length of that. If that length is not 0, then it will continue to do a check. So if it knows that there are definitely markers that have been spawned in the world that have been added to this array, then it will move on to the next stage. If not, then it will skip number 6 and it will move on to number 7 spawn marker, which we'll get to in a second. But let's presume that I've already spawned at least one marker in the world, so it now goes, okay, right, you need to double check that you're not overlaying your new marker on top of another one, and we're just kind of running out of markers but placing them in the same place, because that's obviously going to get very messy. So in order to do that, we have a for each loop with break, and it's using this spawned markers actor array, which we will get to a little bit later. You'll see when we actually spawn an actor in number 7, there's a reference to it there. But we're assuming we've already done that at one point, so we're just double checking that it's not in exactly the same, or there isn't already a marker in the same place. So it checks, it goes through each of the different spawn markers. Within each of those spawn markers, it gets the actor location, and it combines that actor's location again with the X and Y values that we've already calculated back in step 3 for snap item to the world. So these X and Y values are always stored in every spawned marker once that marker has been spawned, and we're checking it against the most recent XY values for the marker that we're trying to spawn. If it is in exactly the same place, the minute that happens, first it breaks the vector search. So once we know that there's definitely one in that same place, we don't need to check through the rest of the array. We might as well stop there, and that sets it to completed, which then goes through this way, and then checks if that value is true or false again. And if it is false, then it will spawn a marker, because there isn't one in place. If that's returned as a true value, then that just stops. Nothing is going to happen. So let's say it got to the end of the loop body, there was no break vector search because that was never true. It completes and it double checks if that's ever basically been set to true. On the assumption that it hasn't, so we're not duplicating, we then move over to number 7 and actually finally spawn that marker. So we've got the X and Y coordinates that have been rounded up, so it's snapped into place from number 3. We use that to create the transform. Everything else, stays 0 values for the rotation. And of course, the scale value is just 1 because we already have the marker the size that we want it in the actor. We use that to create the spawn transform, connect that all the way back into the actor class, which is back here, is the actual, the actor class is survey marker BP, which is this actor class that I've got open here, which we'll return to just towards the end, or come to just towards the end. But there we go, that actually spawns the actor, the transform goes into that. Once that is spawned into the world, it gets added to our list of spawned markers, and then the last thing to do is update the inventory, because originally we had 10, I believe, of these markers in the world when we first started. We have a structure in the inventory, which we've already looked at. So you say, yep, you've got the stack, we've got 10, which are included in that. So it will basically, once it gets to this point and we're updating the inventory, it will go through that inventory structure array. And it will basically look for the stack value within that, reduce that by 1. Everything else stays exactly the same, so it's literally just we're breaking the inventory structure, and we are just translating the item icon over, the item name, everything stays the same, but we just want to decrease that stack value by 1, and then we make that inventory structure, basically reset that. So we've taken out that one array item, made that one change, and then reset that array item, and then we update that visually in the inventory, which if I scroll all the way up to here, basically still takes the inventory structure and then loops through everything in that inventory structure now that it's been updated to update that visually. So now if we were to go over to the actual scroll bar itself, when we're actually in the right place, right clicking, and we can see that's updating to go to 9 and 8 and 7 and 6 and so on. So the last thing, just to very quickly show you, is the code for being able to click on the survey markers and change their color. And that bit's nice and straightforward. There isn't a lot going on here. So it's just using the left mouse button on clicked, which is the default within Unreal Engine. So once you click on the marker, it changes the visibility. If I go into the viewport, you'll see the actual the model, the 3D model, and that's called marker. And then I've just got 3 cubes. All 3 of those, as you can see, they're all just static cube meshes, but they've got different different materials attributed to them, emissive materials attributed to them to give them that nice glow. And if you scroll down, they're all neither visible, they're set to invisible. Probably might more sense to have them visible, but hidden in the game would probably be a little bit smarter to do it, but I've got it as them not being visible. And then when clicked, all 3 of those cubes become visible, and then you have the ability to actually click on those particular cubes, and then depending on which one you click on, so if I click on this particular cube, that changes the color reference to 0. So cube 0 here, it's got this kind of orange light, and then you can see here I've got an array of different materials, the orange light, the green light, and the red light, and then whichever one you click on here, so we click on this cube, that cube itself has the orange light, so the color reference is 0. In the array, you can see the color reference is 0, is the orange light, so it will take the orange light material, attribute it to the marker, specifically element index 2, and you can see in the model we've got a palette for the main part of the marker, and then you've got glass for the see-through at the top, but then the element which can change the actual light color in the center, that's also got its own separate element for material, and we can scroll through and change that to different things. You can see we changed that to green and red, but of course using this code, that's happening actually in the that's actually happening in game in response to pressing the different buttons when we open it. So just do that one more time. Take that, right click, I already left it as red, so there it is, it's red, but if I click on it, we'll go to green, back to red, and to orange. And that is the marker system for the Detectorist Guild. Thank you very much for listening, hope that was helpful.